Okay, before doing this problem, you should have watched the video that has to do with the introduction and talks about the rules. So now make sure you're familiar with these rules before you watch this video. It'll make more sense. So you can look at the notes. The notes are linked there's a link to it in the description of this video below. Or again, you can go ahead and watch the previous video I shot that talked about the introduction to this. So assuming that you've already looked at that already, we're going to go ahead and answer these questions here. This is a setup, but not solving. We're only setting these up, and in future videos we're actually going to go through and solve for the different constants. But this one, they only want you to set it up. So for each of these, what you're going to do is you want to look at the different rules and see which one it matches, and that's the rule that you're going to use in order to break this up. So this one has got some linear factors underneath. So in this case, we want to use rule number 1. So for rule number 1, that says that we start with a1 over the first linear factor, and then we have a2 over the second linear factor, x minus 1. That's actually going to be it. That's going to be your setup. We have a1 over x minus 5 and a2 over x minus 1. Now, depending on what book you're using or what the online homework system you're using, you might have a's and b's there instead. But in this case, we have a1 and a2 goes underneath right above the linear factors. That's all you have to do for part A. Now, for part B, we have an irreducible polynomial inside. If we try and factor this one right here, we're looking for factors of 1 that add up to 1. That's impossible. We can't find two factors that will do that. So, because this is considered irreducible, we need to use rule number 3 in this case. Now, rule number 3, we have to remember, you need to put an x up there. So we're not just going to have a constant like the previous example. You got to actually set it up a linear one like this, a1x plus b1. So then you're going to have x squared plus x plus 1. That's going to be raised to the first power. You don't have to actually show that raised to the first power, but I'm just going to go ahead and showing you the pattern on it. So basically the first one's raised to the first power. Then you're going to do a2x plus b2 over x squared plus x plus 1. Raise the power to 1. This is 1. Now we're going to go up to 2. Then we have to do one more. a3x plus b3 x squared plus x plus 1. Now this is going to be raised to the third power. So this whole thing, this is going to be your setup for part B. Notice we got x's on top of all these. Okay, and these are all going to be different constants. Again, if you want to do a, b, c, d, e, f, you could do that as well. But the main thing of importance in the bottom, we have it raised to the first power, second power, third power. You keep on going until you reach whatever this power is there. And that's going to be it. That's rule number 3. Now this one, we have a linear factor that's raised to a power. That's going to be an example of rule number 2. So rule number 2, we don't have to put the x's on top like last time because it's linear on the bottom. You're just going to do regular constants. So I have a1 over 3x minus 5. And again, this one, I could show it like this to the first power, or again, I don't need to show that. I can just do 3x minus 5. That's to the first power. Plus a2 over 3x minus 5 to the second power. Plus a3 over 3x minus 5 to the third power, plus a4 over 3x minus 5 to the fourth power. So I have all of them, powers are going up, 1, 2, 3, we can stop at 4 because that's the power that you have here. So this would be the setup for all these. And this is the first step that you would do in order to do partial fraction decomposition. So that's the first thing, is knowing how to set it up. So now that we've taken a look at how to set it up, now the future videos I'll show will be ones where we actually break it apart and we actually solve for a1 and a2.